The first question, find the sum of first 30 terms of an AP whose first term whose nth term is given by 7 minus 3n. So when they say the nth term, they are talking about a of n, it's given by 7 minus 3n, and they have asked us to find the sum of first 30 terms. Now when they say a of n is 7 minus 3n, this is the formula we have to use to find the nth term. So using this, we'll find the first term, that is a, equal to 7 minus 3 into 1. So it is 7 minus 3, that is 4. We get a equal to 4. To find d, I'll first find the second term. So a of 2 will be equal to 7 minus 3 into 2. So 7 minus 6, which is 1. Now d will be second term minus first term, which is 1 minus 4, which is equal to minus 3. So we got d equal to minus 3. Now just simply apply the formula and find s of 30. So s of 30 equal to n by 2, that is 30 by 2, into 2a, that is 2 into 4, plus n minus 1, that is 29, into d, which is minus 3. So 2 ones are 15s are, so it becomes 15 into 8 minus plus into minus 87, which gives us 15 into minus 79, which is minus 1185. So the answer is minus 1185. Now the second question, for what value of n are the nth terms of two APs 63, 65, 67 and 3, 10, 17 equal? So they have said the nth term of this AP will be equal to nth term of the second AP. For the same value of n, the two terms will be equal. So a of n of the first AP should be equal to a of n of the second AP, and we have to find the value of n. Apply the formula. A of n is a, that is 63, plus n minus 1 into d, which is 65 minus 63, 2. This is equal to a, that is 3, plus n minus 1 into d, which is 10 minus 3, 7. I'll open the brackets. 63 plus 2n minus 2 equal to 3 plus 7n minus 7. I'll transpose. So I get 63 minus 2 is 61 minus 3 plus 7 equal to 7n minus 2n. So 61 minus 3 is 58. 58 plus 7 is 65 equal to 5n. So n equal to 65 by 5. So n is equal to 13. So the 13th term of both APs will be equal. You can, if you have doubts about the answer in such problems, always apply the formula and check for both APs using the value of n as 13. Okay, now the third problem. If the sum of first 7 terms of an AP is 49, so s of 7 equal to 49, and that of the first 17 terms, that is s of 17, is 289. So this is equal to 289. Find the sum of first 25 terms. So s of 25 is what we need to find. Now again this question, two conditions, two unknowns, that's a and d. Apply the formula and find a and d. So s of 7, that is n by 2, 7 by 2 into 2a, that is 2 into a plus n minus 1, that is 7 minus 1, 6d is equal to 49. I'll transpose 7 on the other side, it becomes 7s are, and when I transpose 2, okay, I'll get 2a plus 6d equal to 7 into 2, 14. I can simplify this further by dividing both sides by 2. So I'll get a plus 3d equal to 7. This is our first equation. For the second equation, s of 17 is 289. So s of 17 is 17 by 2 into 2a, that is 2 into 17 plus n minus 1, 17 minus 1, 16 d. Oh sorry, a is not 17, it's 2a. I'm very sorry. Equal to 289. So now again 17 ones are, 17 17s are. I can take 2 common from here, so it becomes 2 into a plus 8d here by 2 equal to 17. So 2 and 2 cancels. I get a plus 8d equal to 17. This is my second equation. Now using both equations, a plus 3d equal to 7 and a plus 8d equal to 17. A values are same, so I directly subtract so that a goes. So plus a minus a becomes 0. 3 minus 8 is minus 5d equal to 7 minus 17 is minus 10. So d equal to minus 10 by minus 5. So d equal to 2. So I got the value of d. Substituting, I'll substitute it in the first equation. A plus 3d, that is 3 into 2 equal to 7. So a plus 6 equal to 7. So a equal to 7 minus 6. So a equal to 1. So we got the values of a and d. Now we have a and d. So we'll find s of 25. That is equal to n by 2. That is 25 by 2 into 2a. That is 2 into 1, 2 plus n minus 1. That is 25 minus 1, 24 into d. That is 2. So 25 by 2 into 2 plus 48. So 25 by 2 into 50. So 1s are 25. So 25 into 25 is 625. Now the fourth question. Find the sum of all multiples of 6 lying between 300 and 500. Lying between 300 and 500 and all multiples of 6. Remember, whenever you have a question where they say in between, even though 300 is divisible by 6, 300 will not be counted because it's supposed to be in between. So it has to be after 300 and before 500. So we'll find the first term which is divisible by 6 after 300. So 300 divided by 6 is 5s are 30, 0, 0. So it's completely divisible by 6, which means we have to add 6 more to get the next multiple. So our a will be 306. Then to find the last multiple, 500 divided by 6, 6 8s are 48, 20, 6 3s are 18. So there is 2, so we have to remove 2 from here to get the previous number. So our last term will be 498. Now we have to find the sum of all these. So our d is 6 since it's a multiple of 6. So sum of all these numbers, for that we need to find the value of n. How do we find the value of n? Taking the last term as a of n and finding its n value. So 498 equal to a, that is 306, plus n minus 1 into d, that is 6. I'll transpose this on the other side. It becomes 498 minus 306 equal to 6n minus 6. So 498 minus 306. 8 minus 6 to 9, 1. So 192. I'll transpose minus 6 on the other side, plus 6 equal to 6n. So 198 equal to 6n. So n equal to 198 by 6. So 6 1s are, 6 3s are 18, 18, 33. So the value of n is 33. So there are 33 terms. Now we have to find s of 33, which is equal to n by 2. Oh, we'll use the second formula because we know the first and last terms. So 33 by 2 into a plus n, that is 306 plus 498. So 498 plus 306 gives us 8 plus 6 14, 10, 8. So it gives us 804. So 33 by 2 into 804. So 2 1s are 402s are. Now we need to multiply 402 into 33. So 402 into 33 will be 3 2s are 6, 0, 12. Again it's the same thing. So I get 6, 0, 12. So 6, 6, 2, 3, 1. So 13,266. Now the fifth question. The 19th term of an AP is equal to 3 times its 6th term. So the 19th term is equal to 3 times its 6th term. If its 19th term is 19, if it is 9th term is 19th. 19. So 9th term is 19. Find the AP. Find the AP means we need to find the first 3 terms two conditions, we can find two unknowns which are A and D. So if A of 19 is 3 times A of 6 means A plus 18D, 19 minus 1 equal to 3 into A plus 5D. N minus 1, that is 6 minus 1. So A plus 18D equal to 3A plus 15D. I'll transpose A on that side and D terms on this side. So I'll get 18D minus 15D equal to 3A minus A. So I get 3D equal to 2A. Now I can use substitution method in this because I can take A as 3 by 2D and substitute it in that. Or you can use 2A minus 3D equal to 0 and use linear equations and solve it as well. So A of 9 is 19. So A plus 8D equal to 19. Now A is 3 by 2D. So 3 by 2D plus 8D equal to 19. So I'll take LCM. So I get 3D plus 16D by 2 equal to 19 by 1 into 2 into 2. So I get 19D by 2 equal to 19. So 19 cancels. I get D equal to 2. Now I have the value of D. I can find the value of A. So A equal to 3 by 2 into 2. So A equal to 3. Now we can find the AP. So the AP is, first term is 3. Second term is A plus D, that is 3 plus 2, 5. Third term will be 5 plus 2, 7 and so on. Now the sixth problem. Find the common difference of an AP whose first term is 5. So A equal to 5 and the sum of its first 4 terms. So sum of its first 4 terms is half the sum of the next 4 terms. So this is half the sum of the next 4, that is from 5 to 8. Alright. Now they have given us A and there is one unknown, that is D, which we have to find, and they have given us one condition to form one equation for one unknown. But now what is the sum of the next 4 terms? How will we find this? So sum of 8 terms minus sum of 4 terms. This will be the sum of terms from 5 till 8. Sum of 8 minus sum of 4 will give us the remaining sum. So sum of 8, okay. Now we have S of 4 equal to S of 5 to 8 is nothing but S of 8 minus S of 4 whole divided by 2. So I'll take 2 on the other side. So it becomes 2 times S of 4 equal to S of 8 minus S of 4. So now I can transpose S of 4 on this side. So I get 2S of 4 plus S of 4 equal to S of 8. So 3S of 4 equal to S of 8. This is one way to solve. Otherwise you can directly apply the formulas here itself and solve. So I get 3 into n by 2, that is 4 by 2 into 2a, that is 2 into 5 plus n minus 1, that is 4 minus 1, 3d equal to S of 8, that is 8 by 2 into 2a, that is 2 into 5 plus n minus 1, that is 8 minus 1, 7d. Right? Now I'll simplify. 3 into 2s are 2 into 10 plus 3d equal to 2 1s are 4s are, so 4 into 10 plus 7d. Now opening the brackets here, I'll open the inner brackets first. We have to follow BODMAS always. So 2 into 10, 20 plus 2 into 3, 6d equal to 4 into 10, 40 plus 4 7s are 28. So 28d. Now 3 into 20 is 60 plus 3 into 6 18d equal to 40 plus 28d. I'll transpose d terms on one side and constants on the other. So I get 60 minus 40 equal to 28d minus 18d. So I get 20 equal to 28 minus 18, 10d. So d is equal to 20 by 10. So d equal to 2. Seventh question. Two APs have the same common difference. The first term of one AP is 2. So the first term of one AP is 2. And that of the other is 7. So of the other AP is 7. The difference between their 10th term is same as the difference between their 21st term. Why? Okay. They have said the difference between A of 10 of 1 and 2 is the same as A of 21st of 1 and A of 21st of 2. Now both APs, the value of A is different but the value of D is same. So first we will check for A of 10 of 1 minus A of 10 of 2. So A of 10 of the first AP will be 2 plus 10 minus 1, 9D. And of the second AP will be, I put brackets, 7 plus 9D. See, D value is same, so I don't have to write it as D1 and D2. So this is equal to 2 plus 9D minus 7 minus 9D. Plus 9D minus 9D cancels. So 2 minus 7 minus 5. Now we'll check for the 21st ones. So A of 21 of the first AP is A plus 20D minus A plus 20D. So this is equal to 2 plus 20D minus 7 plus, minus 20D. So this and this cancels to 2 minus 7 is minus 5. So yes, the difference of the 10 terms and 21st terms are the same. In fact, any APs which have the same common difference, you take any term, their difference with any number, any value of n, the difference of the terms will be same. Why? Because since common difference is same, each term is increasing by the same value. So each corresponding term of the other AP is also increasing by the same value. So from 10 term to next 11 term, it increases by 2 for this. Probably, for example, one value of D is 2. So it will increase by 2. So for the other AP also, the value will increase by 2. So the corresponding values are increasing at the same rate, which is why when you subtract the corresponding terms, you will get the same answer. Eighth problem. Find the sum of integers between 500 and 1000 that are not divisible by 5. Okay, between 500 and 1000. Now they have asked you to get the sum of numbers which are not divisible by 5. So how do you get the sum of numbers which are not divisible by 5? So first what we'll do is we'll find the sum of numbers divisible by 5, that is between 500 and 1000. So you cannot take 500, you have to take the next number. So A becomes 505 and you cannot take 1000 because it's supposed to be in between, so it has to be before 1000. So the last term is 995. Alright, now I'll find the sum of all numbers divisible by 5. So S of n, that is we have to find the n value. So the last term will take it as A of n, that is 995. So 995 equal to A plus n minus 1 into D, that is 5. So I'll transpose 505 on this side, it becomes 995 minus 505. So 094. So 490 equal to 5n minus 5. Minus 5 comes this side. So 495, it becomes plus 5 equal to 5n. So n equal to 495 by 5. So it becomes 99. So n is 99. So S of n, that is S of 99 equal to n by 2, that is 99 by 2 into, I know the first and last term, so I'll use that, 505 plus 995. So I'll do 995 plus 505, that is 010115. So I get 99 by 2 into 1500, so 750. Now 750 into 99. So 9 5s are 45, 4, 9 7s are 56, 9 7s are 63 plus 4, 67. So this will again be 0576. So 5021, 13, 14, 74,250. So S of 99 equal to 74,250. So what is the sum of all numbers divisible by 5? it is 74,250. Now how do I find the sum of all numbers not divisible by 5? Because sum of numbers which are not divisible by 5 will not form an AP. For example, 501, 502, 503, 504, then the next number would be 506. So the first 4 numbers have a common difference of 1, but in between we'll get numbers with common difference of 2. So what I'll do is I'll find the sum of all numbers between 500 and 1000. So sum of all numbers between 500 and 1000 subtracted by sum of numbers divisible by 5 will give us the sum of numbers which are not divisible by 5. Now sum of numbers, so which are sum of all numbers, so A will be 501, L will be 999 and D will be 1. How do I find the last term? Okay, how many numbers from 501 to 999? It is 499 numbers. Be careful when you do this. So from 501 to 999 are 499 numbers. So we have to find S of 499, that is equal to n by 2 into A plus L. Again we get 499 by 2 into 501 plus 999 is 1500. So ones are 750s are. So we do 750 into 499. So 9 zeros are 0, 9 fives are 45, 9 sevens are 35 plus 4, 39. Again 9, so we get 0, 5, 9, 3. Then 4 zeros are 0, 4 fives are 20, 4 sevens are 28, 30. So 5, 0, 4, 1, 10, 13, 1, 4, 3. So we get 3,43,450. Now we have to subtract that from this. So 3,43,450 minus 74,250. So 0, 0, 2, 13 minus 4, 9, 13 minus 7, 6 and 2. So the answer is 2,69,200. This is the sum of all numbers which are not divisible by 5. The ninth question. A sum of rupees 700 is to be used to give 7 cash prizes. So 700 rupees has to be used to give 7 cash prizes. That means it's to be divided in 7 parts. To students of a school for academic performance, the prizes are for that. If each prize is 20 rupee less than its preceding prize, find the value of each prize. So each prize is 20 rupee less, which means what is the 7 parts? N will be equal to 7, D will be equal to, either you can take it as 20 or minus 20. If you consider the top prize as the first term, then D will be minus 20. If you consider the 7th prize as the first term, D will be first 20. Either ways you will get the correct answer. But we'll take D as minus 20 because in the question they have told that 20 rupee less than the preceding price. So we'll assume we'll take the first prize as the first term. Now we know N, we know D, and 700 is what? The total amount of the prize. So S of 7 is 700. Now we do not know A. Using these three we can find A by application of the formula. So S of 7 equal to 700, which is equal to N by 2, that is 7 by 2, into 2A, that is 2 into, we do not know the value of A, 2A plus N minus 1, that is 7 minus 1, 6 into D, that is minus 20. So we get 700 equal to 7 by 2 into 2A minus 120. 7, when I transpose it cancels, 7 ones are 7 hundreds are, I'll take 2 on the other side. So 200 equal to 2A minus 120. I transpose this, so it becomes 200 plus 120 equal to 2A. So 200 plus 120 is 320 equal to 2A. So A is equal to 320 by 2. So 2 ones are 160. So A equal to 160. So what is the first prize? It is 160. What will be the next prize? 140, then 120, then 100, then 80 and 60. How many are there? 1, 2, 3, 4, 5, 6, 7. So the cash values of each price is 160. For second it is 140, third, fourth, fifth and 5th, 6th and 7th. So those are the values of the cash prices. The taxi fare for the first kilometer is rupee 12 for the first kilometer. For each additional kilometer it is rupee 7. So plus each kilometer it is rupee 7. Find the total fare after 20 kilometers. Okay, so we have to find the total fare for 20 kilometers. Now, if you travel 1 kilometer, you are paying 12. If you travel 2 kilometers, you are paying 12 plus 7, that is 19. If you are traveling 3 kilometers, you are paying 12 plus 7 plus 7, that is 26. So an AP is being formed. This is for the first kilometer, second kilometer, third kilometer. So the number of kilometers becomes your N, and we have to find for 20 kilometers. So N is equal to 20 and the fare is A of N. So now we have A equal to 12, D equal to 7 and N equal to 20. We have to find A of 20, which is equal to A plus N minus 1, that is 20 minus 1, 19 into D. So 12 plus 19 into 7, 9 7s are 63, 7 1s are 7 plus 1, 13. So 13 plus 133 plus 12 is 143, 145. So the total fare for 20 kilometers is 145 rupees. 11th question. Students of a school planted trees around the school to reduce pollution. Each section of each class planted the same number of trees as their class in which they were studying. Each section of each class planted the same number of trees as the class in which they were studying, which means each section of first standard planted 1 tree each. There were 3 sections of each class and there were classes in the school from 1 to 10. How many total trees were planted? So there were 3 sections for each class, and each class is planting the same, each section is planting the same number of trees as the class in which they are in. So now first standard has 3 sections and each section is planting 1 tree because they are in first standard. So total number of trees planted by first standard students is 3. The second standard students, each section will plant 2 trees because they are in second standard and there are 3 sections. So 2 into 3, 6. The third standard students will plant, each section will plant 3 trees. There are 3, so 3 into 3, 9. So the number of trees planted by each section is in AP, that is 3, 6, 9 till 10 standard. So each class is, this is by first standard, second standard, 10 standard, third standard. So if we need from 1 to 10, N becomes 10. And we have to find total number of trees, so S of 10. Now we know A, which is 3, we know D, which is 3, and we know N, which is 10, and S of 10. So S of 10 equal to N by 2, that is 10 by 2, into 2A, that is 2 into 3, plus N minus 1, that is 10 minus 1, 9 into D, that is 3. So 1s are 5s are, so 5 into 6 plus 9 3s are 27. So 5 into 33, so 15, 165. So total number of trees that were planted were 165. Now the 12th question. If sum of first n terms of an AP is an square plus bn, find its common difference. So sum of n terms is an square plus bn. We have to find the common difference. Now like I said, S of 1 is the first term. In previous videos we have discussed this. So S of 1 is equal to A itself. So what is S of 1 in this? It will become A into 1 square plus B into 1. So you get A square plus B. Now S of 2 equal to you can okay, we can directly find a of 2 by using this formula, a of 2 equal to s of 2 minus s of 1. So s of 2 will be equal to a into 2 square plus b into 2 minus, I'll put brackets because minus sign is there, s of 1 is a square plus b. So I get 4a plus 2b. Oh, it's not a square, sorry, it is a into 1 square, that is a into 1, this is not a, so minus a minus b. So 4a minus a, 3a, 2b minus b plus b. So this is our second term, this is our first term. So common difference will be second term minus first term, which is equal to 3a plus b minus a plus b. So that becomes 3a plus b minus a minus b plus b minus b cancels, 3a minus a is 2a. So the common difference for this AP is 2a. The 14th problem, find the sum up to 11 terms of this AP, a minus b by a plus b, comma 3a minus 2b by a plus b, comma 5a minus 3b by a plus b dot dot dot. We have to find up to 11 terms, which means n is equal to 11. We know a, which is this. How do we find d? D equal to second term minus first term minus a minus b by a plus b. Since denominators are same, LCM will be a plus d itself. I get 3a minus 2b minus, remember to put brackets, a minus b. So 3a minus 2b minus a plus b by a plus b. So 3a minus a, 2a minus 2b plus b minus b by a plus b. This is our d. Now we know a, we know d, we know n, we can find s of n. So they have asked the sum of first 11 terms, s of 11 equal to n by 2 into 2a, that is 2 into a minus b by a plus b, plus n minus 1, that is 11 minus 1, 10 into d, that is 2a minus b by a plus b, 2a minus b by a plus b. So this is equal to 11 by 2 into 2a minus 2b by a plus b plus 10 into 20a minus 10b by a plus b. Now again denominators are same, so I can directly take the LCM will be same. So it becomes 2a minus 2b plus 20a minus 10b. I am not putting a bracket because it's a plus sign, so signs will not change. So 11 by 2 into 2a minus 2a plus 20a, 22a minus 2b minus 10b minus 12b by a plus b. So I get 11 by 2. I can take 2 common. So what do I get? 11a minus 6b by a plus b. In brackets 2 and 2 cancels. So I get 11 into 11a minus 6b by a plus b. Now the last 15th problem, which is the first negative term of AP 156, 151, 146. 156, 151, 146. If you remember, to find the first negative term, we know that a of n should be less than 0. We know a, we know d, that is 151 minus 156, so d is equal to minus 4, and we just need to find a of n less than 0. So since a of n should be less than 0, we'll substitute the formula a plus n minus 1 into d, that is minus 4 less than 0. So 156 minus 4n plus 4 less than 0. So 160, 156 plus 4 minus 4n less than 0. So 160 less than 4n. Transpose this. So 160 by 4 should be less than n. So 1s are 40s are. N should be greater than 40, which means n is equal to 41. So the 41st term should be will be the first negative term of this AP.